Hey everyone, welcome in to another daily editorial here on the KE Report. I'm getting an update from Graphene Manufacturing Group, and we're going to be answering a lot of the questions that you have all sent in to me. Thank you, everybody, for sending in all those questions. I've tried to get back to all of you and keep you up to date on when this call was proceeding. And look, we've had so many questions come in. I won't be able to get to them all in this segment, but I'm going to be having Craig back on a more regular basis throughout the rest of this month and into September to answer your questions and follow up on news releases. I am chatting with Craig Nicol, CEO of Graphene Manufacturing Group, traded on the TSX Venture Exchange under the symbol GMG, on the OTCQX under the symbol GMGMF. Craig, as I said, a lot of questions have come in. We're going to be focusing most of this interview on the battery division. Just to let everyone know, company has three divisions: the Graphene Aluminum Ion Battery, Thermal XR, and the lubricants division, as well as the graphene production that plays into all of these products. Craig, quickly recapping a July 6th news release, you provided an update on the battery development as well as next steps towards commercialization. This is all being developed in partnership with the University of Queensland. What's notable about this news release, Craig, and what is that path to commercialization, please?
Yeah, great to be back on, Corey, and always good to chat to you and to answer questions from your listeners. Most notably is the point that the company has held the timeline that we expect to have a battery pilot plant operational in our Richmond's facility. Obviously, we still need to take investment in that and get our batteries to a point which makes that work. But we still hold the timeline overall of having that all operational by the end of next year. So I think that's the main point that we wanted to get across, given the complexities of bringing this to market. And in all of that, we still see that next year, end of next year, we aim to have it operational.
Craig, what about some testing data? I've gotten a lot of questions of people asking, when are we going to see some more testing data? What really matters here to move this product forward, not just with that partnership with Rio Tinto, but also with potentially other partners? What battery data can we be expecting sometime soon?
Yeah, we'd love to share the battery data, obviously, as soon as it's ready. We need it to be repeatable and we need it to be third-party tested before we can announce it. That's just something that public companies, regardless of who they are and where they're listed, need to happen. So that's why we've kept that timeline overall the same, but at the same time said we'll communicate the repeatable and third-party tested battery pouch cell data once we have that at hand. So unfortunately, we're not communicating that, and we would love to have communicated it, but we're not there yet. But we don't see why we need to shift our overall timeline. For the listeners of yours who've been in batteries or been in some way involved in certain type of battery development, understand how complicated they are. We are literally writing the book on a brand new type of cell chemistry. We're learning an enormous amount, and that's the other key point, is that we've developed significant knowledge regarding our electrochemistry in pouch cells since we've achieved the 1 amp hour capacity in February 2024. And that's a really big point. It only proves that we're progressing, and there are many ways of optimizing the cell, and the cell the chemistry is markedly different to lithium-ion cells. And we're finding how to optimize it on both the anode and the cathode and the electrolyte. And that is literally where we're at. We've said we're battery technology readiness level 4, which is a optimization stage that any battery goes through its development. And hence where we are, we've said that we're at BTRL level 4 since early this year. And we're working through the optimization, and we believe wholeheartedly that our overall timeline for commercialization is still on track.
So, Craig, you're working towards getting this pilot plant built and operational, but as you just alluded to there, you do need to lock down what is going to be going into these batteries and the chemistry around it. I had a listener send in a question that indicated that GMG has been going through several sprint programs, month by month, switching up materials. They're curious as to what stage you're at then. Have you locked down, or are you close to locking down what the materials are going to be for the cathode, for the electrolyte, for the separator?
Yeah, I think the answer is no, because we'll probably be managing that right up until the last day of, and even probably through the procurement phase of our equipment. The exciting thing is we have multiple electrolytes, which do all different things. We can vary the voltage by swapping the electrolyte, which is not possible with a lithium-ion battery or other types of batteries. We do things with our cell that are not possible otherwise in other technologies. So what we've had to do is learn these things. We've learnt them through our sprints, which we put in detailed into our press release last week. The sprints are designed to optimize around one particular feature generally. We have very fast cycling cells, extremely fast cycling cells. That has not changed. That's still the same. And so we're able to do many different batteries in much faster time than a lithium-ion battery. So lithium-ion battery, you might have to cycle for a month or two, when we can sometimes tell data after a day or two, because that's how fast our cells cycle. And our batteries form and are activated in sometimes, most times less than an hour. So whereas lithium-ion cells can take 2 to 3 weeks before you actually know that they're working and how they worked. So it's a very different dynamic. We get data very fast. We're doing what every other battery developer does in this space, and we are getting an enormous amount of data, and we'll continue to optimize around all of those different parts of the battery, even past investment decision. If we get there, and we believe once we get there, then we'll get past that, and then we'll find ourselves doing optimization after that. But we've certainly learned an enormous amount since we've announced our 1 amp hour cell.
So, Craig, have there been any significant issues that investors should be aware of with the development of these batteries, with the mixture of different materials, all the testing you're doing here? Again, we don't have that testing data, but any significant issues that you have encountered?
It's a great question. I don't think there is anything that we would necessarily put into significant issues. I think we've come and understood the battery. We have some of the best battery people in the world working with us. I've just literally come off a call on that. I'm working on that exact point around optimizing the next step for next week with one of the best battery guys in the world, Bob Gallion. So I think we've got to push through like we normally do on these developments. This is our third product that we're in developing. We've done graphene, thermal XR, and now into obviously production performance, and now we're into this battery phase, development phase. And, I think what we're doing is learning the normal operating parameters of a battery. So it is what I would call kind of a standard progress or maturation phase of the battery for any company that's doing this work. You've got to almost break the battery to work out what the limits are. And then you go back into that operating regime and work in that space to push it forward. So not at this point. I think we would have definitely articulated that in our update if there was something that we wanted to bring to life. The cell chemistry is remarkably different than any other cell chemistry out there in the world right now. It is so simple, but it's really difficult to make things simple. And you've got to optimize it quite heavily, like any other chemistry, to get that working in a way that works. So yeah, I think we're working through the right items, the right issues. We've articulated how the cell is optimized. We typically make the cell We test it. We get very quick performance data. Sometimes we can get test out data within a couple of hours. It's that fast. It's not like any other battery out there in the space. Then we compare it and then review the next steps within a whole master plan of testing and design of experiment approach. And then we propose the next cell design, and then we typically make the cells the following week, or sometimes it can be the next day. And we've been doing this now for a bit over 3 months, and we've learned an enormous amount in that time, and we feel quite confident that we'll come out the other side with quite a strong optimal cell that we can take to an investment decision around our battery plant.
How about the cost profile of these batteries then? You can quantify the cost of graphene and aluminum, but people are wondering what the cost will be for the electrolyte, for the separator. What insights can you give us on the overall cost profile of the battery and how that's also playing into this mixture of materials?
Yeah, I think overall the company's more optimistic or more encouraged about cost than probably we ever were. So capital cost is one thing and operating cost is the other, and I'll break them out. Capital cost, we've probably got at least 10 to 20% less equipment than a lithium ion battery, and we're using the same equipment. We just don't use some of their components that they use to make it. So capital cost is definitely lower, and we're seeing that we just don't have an anode coating line, for instance. So that's a big part of a plant. We just have an anode line, which is aluminium foil. Another part of the capex, which we don't really know how big this cost reduction will be, but we know it will be reasonable, is we just mentioned our cells take hours to turn on, whereas a lithium cell will take about 2 to 3 weeks. They got to wake them up slowly so they don't disturb the chemistry. So what that means is you just have far less charging stations and what's called stacking. And that is a massive difference in electrical power, capital. You've got to put the power into the building because you just don't have as many cycling at the same time. We're typically 50 cycles and we're done, and we can charge it much faster than a normal lithium cell. So that's very different in terms of how a lithium cell gets woken up. So capital is definitely less structurally, with the same capital kind of equipment otherwise. So with product cost, I think we're getting a whole lot more optimistic about that too, because one of the biggest costs to operationally to manufacture a lithium cell is the heating or the drying out of the coating. Now we've only got one coating line and one drying line. So that means we've got a lot of heating costs we can remove in the anode heating line, which is actually quite a big chunk of operating cost. We don't have any other strange materials that we need to import from other processors or nanomaterial producers. But the electrolyte is highly likely to be the one that we go with in the end, or the one that we think will push forward with the main product area, is basically going to be probably a urea and aluminium chloride outcome, which obviously are quite a low cost product material to buy. And then when you look at the average cost of a lithium ion battery operating cost, it's about 30% or so is actually the cost of the charging and the waking up of the battery. So from the operating cost point of view, I think we're going to see a much reduced cost there just because our charging is faster. So I think from a point of view of making the graphene, getting it into a kind of a battery ink, we've definitely come a long way there. We aim to communicate more information on that shortly. And then the aim to then make a low cost electrolyte and then a low cost scalable cell and form it. I think all of those costs are coming in line probably better than what we expected. So overall, capital and product costs, I think we're feeling pretty optimistic.
All right, Craig, I do also have to ask you about this agreement with Rio Tinto. This deadline at the end of June has passed. People are wondering, were prototypes delivered? Were cells put in the hands of Rio Tinto for testing? What update can you give us on this front?
Yeah, I'd love to go into that detail, but I think it's probably best I don't, because it is between GMG and Rio Tinto. But suffice to say, we've said this in our release, that we will release the information on the cells once we have the repeatable third-party data. We need third-party and repeatable data before we can announce it to the public, and that's what we've said, and that's what we'll maintain. So once we have that, we will release it, because that's what we've said we would do, and we obviously got to the next stage of being able to announce that. So I think that's probably the best way to say how we can go forward there.
Okay, so everything is moving forward with Rio Tinto, though. People were worried that maybe this whole partnership had fallen through.
We have no concern there.
Now, what about using the company's resources to develop this pouch pack for Rio Tinto? But you have also made the comment that there are other interested parties that you could potentially develop batteries for. How are you allocating your team's time to potentially take advantage of both of these opportunities?
Yeah, this is a really challenging point. As we've progressed and as we've got our name out just through sheer internet links, not necessarily doing any marketing per se, because we don't seem to need it. We're getting some pretty substantial companies coming and trying to work out how they can work with us in the battery space. And we've had a couple recently, very large manufacturers in the space. So it is broadening our application offerings and also the partners that who are interested in working with us. And we're currently working out how to make and bring all that together. So I think from a point of view of opportunity to commercialize it, we've said there are many different sectors. Diesel engine replacement in high power load, that's obviously the Rio Tinto application up front, is definitely still very strong. The high power discharge is a really strong battery parameter that we have. Also the safety, those two things really matter there. The energy storage is certainly another area that we can help with. EVs, and certainly in high performance vehicles, that's another area that's highly attractive to some companies in that space. Aviation, certainly electric vehicle, vertical takeoff and landing, eVTOL, also very helpful. Rail safety is the biggest factor there. We've had conversations going on there. Personal electronics are going to be around the really fast charging opportunities and also the long life. And then the power tools, again, around the fast charging and long life. So really broad, different applications, but they'll come in as we develop the battery in different ways, and that'll become apparent. We've probably got different companies in all those different areas we're working on in some way. There's a lot of companies we know who are just waiting for us to get to the next stage. They've told us so. Some very large companies have just told us that they're just waiting for us to develop it. To be quite frank, that's a bit frustrating because we're a pretty small company trying to develop this massive new technology. It'd be great if they could come and work with us, but they've got their things they've got to work through. So we'll really be looking at ones who want to partner with us and take us and joint develop it and take some risk, if you like. That's the companies that we want to work with. And then as the others come, we'll see what they do. But yeah, there's nothing in this that we see that we can't say what we said we were going to do. So we just got to work through it, though. It's difficult. It's difficult work. Batteries are literally a living biological chemical structure. And only when you see them get started up with their first charge and discharge do you really understand that. Until you start them, they're just a bit of chemistry and a bit of metal. Once you start their electricity, they actually are acting like a living thing. And when you understand that, you then understand how complicated they are and how, that they can get into different spaces that you don't want them, and you move them back out into other spaces. So, I think in total, we've made really good progress, learned an enormous amount. And as I said, we've kept a high level overview of commercialization there. And I think that'll come true as well.
So if there are a lot of companies that are waiting for you to develop this chemistry a bit more, maybe come out with some more concrete prototypes, does that mean a final investment decision is further down the road? Right now, you'd just be looking for partners, ones that would, I guess, provide some capital, some insights, rather than some sort of concrete final investment?
It's a great question. And I think the board has really got to make its mind up on that. I can't necessarily say that we will definitely move ahead with a battery pilot plant without, say, another partner. But Rio Tinto arguably has more demand for our cells once we get there than us that we'll be able to make for some years. So you go, well, do we need much more potentially? But do we want more than one or two or three customers? That's a good question. I think there's another angle to this, and that is when you start producing in automated fashion, you get a lot better repeatability. We are doing manual cells. Our scientists and engineers make the cells every day, and they're amazing. I can't do it, but they can, and they make these cells and highly accurate cells. You're talking multiple layers, enormous amount of precision. When you go to that automated factory, you get a whole lot of higher quality outcome. It's just a fact. So yeah, the more batteries you make, somehow the better quality they get. So there's another point of just general progression of the company that the board may actually say, well, we actually just need to get to the next level of quality. And this is what we just need to do to get there. And that could very well be the case as well, Corey, that we need to progress. We need the factory to make that happen. And then we come out the other side with a much higher, very likely a much higher quality cell and a much higher performing cell as a result.
Okay. Craig, do we need to be aware of any competitors working on somewhat similar battery chemistry that GMG is working on that could maybe challenge some of your IP, or in a way, if it doesn't move along faster, could actually take some market share from you?
It's a good question. I think you always got to be as best as you can on the day and get work done as fast as you can and as best quality outcome as you can. There will be people who come along and develop some kind of aluminium ion battery chemistry eventually. And if there isn't, then it probably means that we have not a good battery, because the lithium battery is made by many companies and was originally developed by Oxford University. So there you go. How many companies are making it now? That's an LMNC battery. So I think, but in general, what we see is the cathode is constrained by the graphene quality. So any aluminium ion battery with a graphene cathode or a carbon cathode has to be extremely well integrated, or in effect have its own graphene plant. That's what we see. That's what we continue to believe. The integrated graphene and battery development is core to this battery program. We are heavily integrated basically on a daily basis between our graphene team and the battery development side of the team. And that'll only be further integrated going forward. We have great data on both sides, and we have data analytics. And so one day I'm very sure that we'll have machine learning or AI over that as well, to be able to optimize the best graphene for the best battery. And it has to be completely integrated. Now, can somebody do that without having a graphene in their business? Yes, I guess they can. But geez, it's a lot harder. And it's already hard enough to develop this type of battery or any new battery. So that's how I see it. I see eventually we will have competitors. Is the market big enough for lots? Yeah, there are. The market's just effectively limitless as we go through this transition. I don't believe that the transition is in any way stalled. It's just being corrected for an over-exuberance belief that battery manufacturers can make 1 billion batteries the next day. Yeah, market knowledge has improved. We will come back on to the energy transition. It'll be longer than what people expected to get there. And it may not be 100%, but it'll be a long way to 100%. And in that time, there's an enormous amount of decarbonisation that needs to happen. And our battery is right in the middle in terms of its specifications and all of that. So I think the market is massive over decades. And we think that we probably got the best way to optimize the cell performance with our integrated graphene production. So all of that together, we feel like that we have the right integrated business model for this. So let's see.
Okay. Yeah. Hey, this battery sector is very, very interesting. There's a lot of innovation going on, and there's a need for a lot of batteries, different forms of batteries too. That's why I think I'm getting so many questions on this battery division. I'm going to leave the battery division, get a Couple other answers from you in some other areas. One being graphene production. Any challenges around the scalability of the graphene production within the company to support the battery division, thermal XR, and the lubricants division?
So, no, in fact, we're issuing a release on that. There are no concerns. It's the opposite. So I look forward to having that release out shortly and the detail around that. But no, there are no concerns about that. In fact, it's the opposite. It's getting better than we thought.
Okay. What about thermal XR and even the G lubricants in terms of generating revenue here? One of my listeners really just laid it out and said in the next maybe year or two, seems like G lubricants and thermal XR are potentially going to be the main revenue drivers. Any updates you can give us in terms of revenue coming from these divisions?
I think we're continually focusing on revenue in this space. The opportunities are growing larger and getting more developed, and we aim to put out a press release on that shortly as well. I think the world is opening up to what we can do. It's another way of saying we're very, very, very busy, and we can see, the end of life on quite a large number of opportunities that are completely game changing for the company and for our customer, potential customers. So I probably shouldn't say more than that, but that in the end is absolutely the growth that we're focused on in getting those sales in and converting our technical work into real revenue.
All right, Craig, we'll wrap it up here. Thank you, everyone, for sending in those questions. I still have a number of questions to get to, but I'm going to save some of those for future interviews, as I will be chatting with Craig, I believe, next week, hopefully, and throughout the rest of this month. So please keep on sending me your emails, your questions. I'll add them to the list by covering all of what you're asking and some of the news releases out of the company. So, Craig, again, thank you very much for your time. I'll post a link to the company's website below, and I'll follow up as some more news is released and to get more of these questions addressed. Craig, thank you again for your time.
Thanks, Corey.